Hello everyone and welcome to MJ's Maths and Stats, preparing ourselves for WIPRO Elite NTH 2020 examination. And this time we will win WIPRO. The different topic on which questions are designed are basically divided into four parts: number system, question on divisibility rules, HCF, LCM, remainder theorem, last digit, factorial, simplification, fractions, types of numbers, arithmetic and algebra, SIRS, indices, log, question on ages, equation, quadratic equation, interest, average, percentage, profit and loss, time and work, time, speed, distance. Geometry and mensuration always form part, like 2 to 3 questions are there from triangles, circles, 2D, 3D mensuration, and obviously modern mathematics, set theory, Venn diagram, permutation, combination, and probability. Once you see the question, pause the video, try to solve it by yourself, and then come back to see the solution. That should be the drill. In the third episode of Win WIPRO series, I've selected few hand-picked questions from number system. The LCM of two numbers x and y is 204 times its HCF. LCM is 204 times HCF. Their HCF is 12. That means LCM is 204 into 12. And the difference between numbers is 60. Then what would be the sum of two numbers? Now we have that HCF is 12. Then the numbers can be 12a and 12b. Let it be x and let it be y. We know that 12 into a minus b is 60. Now, since HCF is 12, a and b are co-primes. So product of two numbers is equals to LCM into HCF. And LCM is 204 times HCF and HCF is 12. Isn't it? 12, 12 gone. That means A into B is 204. Now in factorization, 204 is 2 into 2 into 3 into 17 or 12 into 17. Now the difference here is 5. We know that A minus B should be equals to 5. That means A and B is 12 and 17. Then what is x plus y? X is 12 into 12. Y is 12 into 17. Therefore, x plus y is 12 into 12 plus 17 is 29. And 12 into 29 is 348. How many three-digit numbers have the difference between them and their reverse equal to 11 times the sum of their digits? Let my number be ABC. Then reverse would be CBA. Let me assume that A is greater than C. Then what is ABC minus CBA? That is equals to 11 times the sum of digits. Now ABC minus CBA is 100 here and 1 here. That will give me 99A. BB cancel out in this. Here we have 1 and here we have 100 minus 99C. So 99 into A minus C equals 11 into A plus B plus C. Isn't it? 9A minus 9C equals A plus B plus C, or we will get 8A equals B plus 10C. Now it's easy for us to frame numbers. Let us do it. We are independent to pick up 1. Let me start with C. If C is 0, B would be equals to 8A, A1, it would be 8. If 70, 72 is 9, and then as I put C equals to 8, it becomes 80, and then 80, if I put B equals to 0, A will be 10, then not possible. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers are here where A is greater than C. Now if I reverse these, this would be 0, 8, 1, which is not a 3-digit number. Otherwise 1, 2, 3, 4, 5, 6, 7, 8. We will have 8 more numbers where A is less than C. So 9 plus 8 is 17. You have 17 of such numbers. If n is factorial 1 plus factorial 2 plus factorial 3 till factorial 10, then what is the unit digit of n to the power a is n to the power n? That means we are looking out for unit digit of n to the power n to the power n. Okay, so what would be the last 2 digits of this expression? Factorial 1 is 0, 1, 2 is 0, 2, 3 is 6, 4 is 24, 5 is 120, 6 is 720, 7 is 5040, 8 is 40320, 9 will end with 80, and 10 will end with 00. So quickly let's add up: 13, 3, 1, 3, 5, 7, and 15, 19, 21. So last 2 digit is 13, and we actually know that. That means we are looking out for a number which ends with 13 to the power a number which ends with 13 to the power a number which ends with 13. We are looking out for the last digit of this particular sequence. Now, the last digit of the base number is 3, and we know that 3 follows cycle of 4. So, when I divide this particular power, the second stage number, by 4, I just need to divide last 2 digits of this number, and that was the reason I calculated last 2 digits for this particular n. Now 13 when divided by 4 leaves remainder 1. Now 1 to the power anything is also 1. That means last digit of this expression is 3 to the power 1, that is 3. How many squares are there in 5 inch by 5 inch square grid? If the grid is made up of 1 inch by 1 inch square, these all are 1 by 1. Okay, we should know the drill for finding out number of squares in a cardboard, on a like checkerboard, something where we have R number of rows and C number of columns. The number of squares are R into C plus R minus 1 into C minus 1 plus R minus 2 into C minus 2 till one of them reaches 0. In our case, we have got number of rows 5 and number of columns are 5. Here R is equals to C. So we have another drill. If R is equals to C equals to X, let the number of squares would be x into x plus 1 into 2x plus 1 by 6. So here we have got R is equals to C is equals to 5. So number of squares which we can see on this particular 5 into 5 grid would be 5 into 6 into 11 by 6. That is 55 squares. Option B. If x is the smallest number that is divisible by both 6 and 5, that means x is LCM of 6 and 5, that is 30. So the smallest number is 30. Then the power of 10 that would be completely divide the product of first 20 multiples of x. So first 20 multiples of x and its product. It would be 30 into 1 into 30 into 2 into 30 into 3 till 30 into 10, isn't it? So this would be 30 to the power, sorry, we need to take 20 multiples, 30 into 20. So 30 to the power 20 into 1 into 2 into 3 till 20. So I can write this as 30 to the power 20 into factorial 20. Now, to check that how many tens can divide this particular expression, we need actually powers of 2 and we need powers of 3 in this particular expression. And we know the drill for powers of 2 and 5 for a given factorial. Factorial 20 when divided by 5 gives you 4. That means factorial 20 is fully divisible by 5 to the power 4. Now no need to check for 2 because 2 would be always in abundance in this particular expression. We just need to check for 5. Okay, so we have this is 3 to the power 20 into 2 to the power 20 into 5 to the power 20. This 3 to the power 20 is divisible by these 3 primes and the powers, and factorial 20 is perfectly divisible by 5 to the power 4. So let me write 5 to the power 4 here. Now how many 5s do I have? 5 to the power 20 plus 4, that is 5 to the power 24. That means the given expression E is fully divisible by 5 to the power 24, which gives us a clue that it should be fully divisible by 10 to the power 24. Why? Because 2 powers will always be in abundance more than 24 in this particular expression, isn't it? So what is the highest power of 10 which can divide this given expression is 24. The largest integer that always divides the given expression for all natural number n is what? Let us see what is this number. N to the power 5 minus 5n cube plus 4n. Okay, n common, n to the power 4 minus 5n square plus 4. 5 is 4 plus 1. 4 is 4 into 1. So that will be n into n square minus 4 into n square minus 1. Bingo. So this would be n into n minus 2 into n plus 2 into n minus 1 into n plus 1. Now can I write this as n minus 2 into n minus 1 into n plus 1 into n plus 2. Product of 5 consecutive natural numbers. N is a natural number, n is given, n value should be 1 or more than 1. So now product of 5 consecutive number is always divisible by factorial 5. We know that. If you want, we can take up any example. 1 into 2 into 3 into 4 into 5. It gives us simply 120, that is factorial 5. That means the largest n which would be dividing this given expression would be factorial 5, that is 120. The sides of a rectangular field is a meter by b meter, where a and b are natural numbers. The perimeter of the field is 78 meter. That means twice a plus b is 78. A plus b is 39. The field is divided into 13 regions of area k square centimeter each. That means area of rectangle should be 13k. And we know that should be equals to a into b. That means a into b should be a multiple of 13, because it's given that what is the value of k if it's a natural number. If it's a natural number, then a into b should be multiple of 13. That means either a or b or both should be multiple of 13. Now can we break this 39 of a into b such that we get 13 somewhere? A plus B is 39. If I take 13, then it would be like 26, because you know that 39 is 13 into 3. That can be 1 plus 2, obviously, or and nothing else, isn't it? It cannot be 3 plus 0. So it has to be 13 into 1 plus 2. So we have 13 and 26. So 13k is 13 into 26. We cancel out 13. K is equals to 26. A child was asked to add few natural numbers starting from 1. That means he is supposed to do something like this, where he is supposed to give me the total like this. So long his patience permitted. As he stopped, he gave the sum as 575. He gave this as 575. When the teacher declared the result wrong, the child discovered he had missed one number in the sequence during addition. What is the mixed number? And we have a very simple drill to find this, because this is a peculiar sum of triangular numbers series. You can watch the entire video of triangular number series on our playlist Magical Numbers. You can find the link on the icon showing at the corner. Click on it and do watch this video for detailed analysis. And now, what is the trend to find these kind of questions? Solution is simple 2 steps solution. 575 multiplied by 2, that would be 1150. Now simply find the root of 1150, a closest root, that is 33. Now just find the total n into n plus 1 by 2. If n is 33, it would be 33 into 34 by 2, 33 into 17, that is 561. This is way smaller than 575. You may try now with 34. 34 into 35 by 2 will be 35 into 17, that is 595. That means he should have given us a total of 595, but he have given a total of 575. That means he have missed out on number 595 minus 575, that is 20. 2-step drill to find the missing number. So my answer should be, the number he missed was more than 15. The owner of a jewelry store hired 3 watchmen to guard his diamonds, but a thief still got in and stole some diamonds. On the way out, the thief met each watchman one at a time. 1, 2, 3 watchmen. To each he gave half of the diamond he had then, and 2 more besides. He escaped with 1 diamond. How many did he steal originally? So half addition, what is left? He started with x. Now you need to self off the half of it. That means you have given x by 2. Now he is left with x by 2. In addition to that, he gave 2 more besides, given 2 more. That means he is left with x by 2 minus 2. Now again he gave half of this, half of x by 2 minus 2, left with similar thing, given 2 more, so left with half of x by 2 minus 2 minus 2. Again give half of this particular, left with half of x by 2 minus 2 minus 2. Again gave half, isn't it? Half of this particular, and again gave 2, and now he is left with 1. Why to frame these kind of equation? It's always troublesome. So the best way is not this way to solve this question. It should be logical, and we should start from the end. He's left with 1. He's left with 1 after giving 2. That means before this stage he have 3. Now he have 3 because he have give half of it what he had actually in the third stage. So you should have started with 6 in third stage. That means 6 diamonds are left with him at the end of stage 2. This is 6 which is left with him after he have given 2. That means he should have started this position at 8. Double of 8 is 16. 16 plus 2 is 18, and double of 18 is 36. That is the simple drill. You have started with 36 diamonds. Gave away half, left 18, gave away 2 more, left with 16. Half of 16 is 8, left with 8, gave away 2, left with 6. Half of 6 is 3, gave away 2, left with 1. Always use the backward format and some logic to solve these kind of questions rather than using algebra in number system. I'll suggest you people to use arithmetic in number system. How many times digit 6 appears if you count from 11 to 160? Digit counting. You will find a very wonderful detailed video on digit counting in our playlist number system. Details are given in the description, or you may click on this icon appearing on your screen. Let's count it now. Now what is the drill then? Drill is from 1 to 99, any digit from 1 to 9 appears 20 times. So we have that count with us, 20. Now we are counting from 11. So from 11 onwards we have left with 06. That is not to be counted in this 20. So minus 1. Now from 100 to 160, how many times the digit 6 will appear? It will appear in 106, 116, 126, 136, 146, 156 and 160, isn't it? As simple as that. 1, 2, 3, 4, 5, 6, 7. It will appear 7 more times. So this is like 27 minus 1, 26 times. Digit 6 appears between the count from 11 to 160. Thank you everyone for participating. I'll see you soon.